Good morning. Welcome to day 3 of polynomial functions. Today, our objective is to find imaginary roots given one rational root. And so what we're going to do is we're going to either find that one rational root either by graphing it or it may be given to you. Then once we find the rational root, we're going to use synthetic to find the quadratic factor. And once we have the quadratic factor, then we can use the quadratic formula. Sometimes we may be able to use just the simple equation to find the imaginary or the irrational roots. So let's just begin. We're given a function x cubed minus 8, and we're going to graph that. So if you see on the left, that's graphed, and we see that it has a rational root at 2. It crosses the x-axis at 2, so it has a real root or a rational root at x equals 2. So one of the things that we can do, so what we're saying is that x minus 2 is a factor. That's what that means. X minus 2 is a factor. So if x minus 2 is a factor, I can divide that into x cubed minus 8. So we could either use long division or we could use synthetic division. We're going to use synthetic division. So we'll have 2 will come on the outside. And remember, each polynomial, each term has to be represented. So I have to write that like this, because this is the same as saying x cubed plus 0x squared plus 0x minus 8. Every term has to be represented. So if you recall from synthetic division, the 1 comes down, and then we multiply and add. So 2 times 1 is 2. We add. 2 times 2 is 4. We add. 4 times 2 is 8. And if we've done this correctly, our remainder should be 0. So that means this is our quadratic factor. So x squared plus 2x plus 4 is a quadratic factor. I could actually write this as x minus 2 times x squared plus 2x plus 4. So I have a linear factor and a quadratic factor. So I know I have a real solution at 2. How do I find the solution at x squared plus 2x plus 4? Well, we can use the quadratic formula because we have to say x squared plus 2x plus 4 is equal to 0. So now we can use the quadratic formula. Recall the quadratic formula is negative b plus or minus the square root b squared minus 4ac all over 2a. Okay? So that's going to give me negative 2 plus or minus the square root 2 squared minus 4 times 1 times 4 all over 2 times 1. So I have negative 2 plus or minus the square root. I have 4 minus 16, which is negative 4 all over 2. So also recall from before, we've talked about that if we have negative 4, that can be written as the square root of negative 1 times 4. The square root of negative 1 is I, the square root of 4 is 2, so I can say that this is a negative 2 plus or minus 2I over 2. And since they all have a 2 in common, I can factor out that 2, and I get negative 1 plus or minus I are my solutions. Okay? All righty, so that's how we do that problem. So remember, what we're doing is we're finding a real root, then using the real root to find the imaginary roots. So it has a root of 2, and it has an imaginary root of negative 1 plus I, and it has a root of negative 1 minus I. Those are the imaginary roots of this function. Because remember, because it's cubic, it can have as many as 3 solutions. Alrighty, let's do the next one. I've already put that into Desmos here so we can see. I've graphed it, and I can see that it crosses the x-axis at 4. So it has a solution of 4, which means x minus 4 is a factor. And I'm doing x minus 4 divided into x cubed minus 4x squared plus x minus 4. Again, you can use long division. I find synthetic division to be easiest here. So I'll put 4 here. I write my coefficients, which are 1, negative 4, 1, negative 4. It's like a little symmetry going on there. My 1 comes down, and then I just multiply and add. So 4 times 1 is 4. That's going to give me 0. 4 times 0 is 0. It's going to give me 1. And remember, if I've done this correctly, my remainder should be 0. So I can write this as x squared plus 0x plus 1. So I'm coming over here and I'm solving this. X squared plus 1 equals 0. Now I could use the quadratic formula, but it would be easier just to remember I can write this as x squared is equal to negative 1. Now in the past you would have said, well, there's no solution. There's no real solution. There is an imaginary solution because this becomes the square root of negative 1, which we know from before is I. So my roots are 4 and then I and negative I. Those are my roots. Okay, let's do one more. We're going to graph this, and again, if you come over to my handy dandy Desmos, I've graphed it for you already, and we can see that it has the solution at negative 3. So one of the factors is x plus 3, so I am dividing x plus 3 into this function to find the other factor. So over here, I forgot to say, we can write this as x minus 4, and we can write it as x squared plus 1. Okay, so let's find our other factor. We're going to start with negative 3. We're going to write our coefficients, 1, 3, 5, 15. The 1 comes down. This should be 0 if I've done it correctly. So so I have 1. Negative 3 times 1 is negative 3. That zeroes out. Negative 3 times 0 is 0. I add, I get 5. Negative 3 times 5 is negative 15. And look at there, it's zeroed out. And so I have an answer of x squared plus 5x plus 5 equals 0. So my factors for this are x plus 3, and then I have a quadratic factor of x squared plus 5. Now, if I have a quadratic factor that's a binomial, I can simply write this as x squared plus 5 equals 0. I get x squared is equal to negative 5. X is equal to plus or minus the square root of negative 5. Remember, the I comes out, so this is x is equal to plus or minus I radical 5. One last problem. So I've already, using Desmos, I've graphed it, and I can see that I have a solution at negative 2, which means x plus 2 is a factor. Also, I'm missing the x squared term, so this has to be 1, 0, 1, 10. And if I've done this correctly, that should be a 0. So I bring down my 1. Negative 2 times 1 is negative 2. Negative 2 times 0 is, negative 2 plus 0 is negative 2. Negative 2 times negative 2 is 4. 1 plus 4 is 5. Negative 2 times 5 is negative 10. And that's zeros. I'm always like, is that going to work? It always works because math is beautiful that way. So my quadratic function becomes, my quadratic factor is x squared minus 2x plus 5. So I can write this as x plus 2, x squared minus 2x plus 5. All right, what do I do with that? I will now have to use quadratic formula on that because it's not a binomial. So using quadratic formula, I get negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 5, all over 2 times 1. So that is 2, because a negative makes that positive, plus or minus. This is 4 minus 20, negative 16, all over 2. Negative 16 can factor out to be 2 plus or minus 4i, because the square root of 16 is 4. The square root of square root of negative 1 is I, all over 2. And so once again, since all of these are a factor of 2, I can write this as 1 plus 2i over 1. So those are my factors. My factors are, my roots are negative 2. That's my real root. My imaginary root is 1 plus 2i and 1 minus 2i. Those are my factors, okay? So on the next page is practice, it's homework, and the answers for this will be in your Google Drive. Okay, boys and girls, so here, let's recap this quickly. The first thing you want to do is you want to graph it to find your real root, or it may be given. It may tell you that the real root is 2. Then you use synthetic division. You divide the original equation, the original function, by x minus 2. So we use synthetic division to do that. We get our quadratic, and then we either solve that quadratic by using the quadratic formula, or if it's just a binomial quadratic, we can just set it equal to 0 and solve it with the simple